Hi guys, so in this video I'm going to talk about what happens when the vectors are multiplied to scalars which are negative. So basically multiplied by negative numbers, negative constants or negative scalars. So let's assume we have this vector here, and let's assume we have 2 by 1 vector only as of now, and 6 and maybe 2. Let's have this vector, let's name it v1. And then we have a scalar s1 which is minus 5, and we have to multiply it. Now what happens when we used to multiply the vector with a positive scalar? Then what used to happen? Either it used to dilate the vector or it used to contract the vector, depending upon whether the scalar is more than 1 or it is less than 1. So, less than 1 but more than 0, of course. So between 0 to 1, if it is 0 to 1, between 0 to 1, then vector will be contracted. If the scalar is more than 1, the vector would be dilated. But what happens if the scalar is negative? So again, as far as magnitude is concerned, it will have the same effect. Either it will be dilated or it will be contracted. The only difference from the positive scalar multiplication will be that the direction of the vector will change when it is divided to multiplied to a negative scalar. So in this case, the result would be 5 into 6, 30, and but we have minus sign with 5, so minus 30. 5 into 2, 10, but we have minus sign, so minus 10. So here, now if we plot it in a simple x, and this is the origin. Let's say this is x-axis, this is y-axis, and let's first plot 6 comma 2. So x would be somewhere around, let's say 1 2 3 4 5 and 6, and y would be 1 2 3 4 5, and so the point would be somewhere here, 6 for x and 2 for y. So this is 6 comma 2, this point, right? Now, so the actual scalar would be something like this. I'm sorry for the for not having this straight curve. It is supposed to be a straight arrow, but yeah. So this is how the normal vector will look like. But when it is multiplied by minus 5, how it will look like? Minus 30 and 10. So minus 30 is x. We already know that the first row is x, second is y. First is x, second is y. So minus 30 would go somewhere very far from here, maybe somewhere here, very far. And minus 10 would be somewhere downside, right? So it would be somewhere here. And don't go by the proportions actually right now, because I know. Uh, or maybe let's do this. Let's have a smaller number here. Why not to have 2 here? Let's have 2 here. So we can have basically, let's say we have 2 here. The answer would be 12 here. Here it would be 12. And here it would be 4. So now I can say this can be 12 actually, 6, yeah, or maybe nearby 12, and 4 would be somewhere here, which is fine. Minus 4, minus 12, minus 4. So point will be somewhere here. So now initially the arrow was like this. Now the new arrow would be like this. something like this, right? So if you see, the magnitude has increased, of course, but the sign has also increased, so direction has also is exactly opposite. If you see, the direction has become exactly opposite. So now, and what if this had been a positive number? What if this had been plus 2? So the answer would have been, with plus 2 it would have been 12 and 4. So in that case, the vector would have been something like this. So see, if it had been a positive number, the answer would have been 12 comma 4, then the vector would have gone like this. So only magnitude has increased. But when the scalar is negative, in this case, so answer is minus 12 minus 4. So of course the magnitude has become doubled, but also the direction has changed. Direction has become opposite. So this happens when we multiply the vector by a negative scalar. So yep, thank you.